You can't be an introvert in data science. I know, you picture this job with headphones on, notebook open, and no one talking to you for 8 hours. But that's not the job. E-commerce runs on data more than almost any other industry, with every click, every card, every abandoned checkout logged and measured. Somewhere behind every one of those numbers is a room full of people who each think they get to decide what success means and don't agree with each other. Marketing wants a click-through, finance wants margins, merchandise wants something that makes sense. And all those are looking at the same model, and that's not a modeling problem. You can't train your way out of it. So before you get mad at me in the comments, I know you can be an introvert and still do those things. So yes, data science isn't completely incompatible with introversion. But if you are that person who only wants to be headphones on coding and you don't want to invest on this skill, then you're gonna have a bad time. I had to learn this the hard way across 3 separate projects, 3 separate lessons. And once you've been through all 3, you start spotting patterns everywhere. The first one hit me 2 weeks after launch, in a meeting that I was nowhere near prepared for. First job, first real e-commerce project. Building a recommendation engine. The brief was simple, predicting what customer is likely to click. So that's what I optimized it for. 94% accuracy. The CEO loved it, the stakeholders signed that off. 2 weeks later, it got pulled out from production. And here's what happened. Predicting what someone is most likely to click is mostly predicting what they're gonna buy anyway. Customers are looking at running shoes and you recommend socks. Technically correct, but also useless. A month in, someone in that meeting asked the only question that actually matters to the business. Has the average order moved at all? And it hadn't. No one had ever told me that AOV was the real goal. I would have picked predict the click because it was the easiest thing to train the model on, and not because anyone has agreed it was a success. I would have made a decision about whose definition counted without realizing that I made a decision at all. Lesson number 1 that shows up everywhere in e-commerce, and not just recommendations. You default to which number is the easiest to measure and quietly call it the obvious one. Different project, same kind of company. A churn model that flags customers likely to cancel. Retention's whole job is keeping customers, so to them, success is obvious. Did the flag customers stay or go? Lower the cancellation number and you have 1. Finance looks at the exact same model and sees something else. Every customer that the model flags get a retention offer, like a discount code, a free month, or something with a real line item cost. So finance question isn't do they stay? It's how much do we spend saving customers who were never going to leave in the first place. Both things are right. Both definitions are reasonable for an e-commerce business you care about, and they are actively pulling against each other. The model that makes the retentions happiest by flagging as many possible churns as it can catch is the same model that makes finance furious because it's also handing out discounts to a pile of loyal customers who didn't need one. There was no model fix waiting to solve this. The actual work was getting the retention and the finance in the same room and asking out loud which kind of mistakes that the business would rather make. Lesson 2. It's not that no one has a definition. It's that 2 teams have a different one and both think theirs is the only sensible one. Third scenario. A model gets built against a clear, agreed target. Say a specific growth KPI that the company sets at the start of the quarter for their online store. Everyone signs off. Work begins. Halfway through the quarter, priorities shift, and margins get squeezed somewhere else in the business, and leadership pivot from growth orders to protect profitability. Nobody told the data scientists. Why would they? From where the leadership sits, this is a strategy update and not a data science update. Weeks later, the finished model lands in someone's desk, built perfectly against a target no one's been measuring for a month. And it's not wrong, it's not even late, it's just answering a question that the business stopped asking. And this one stinks more than the others because there's nothing you could have caught up front. The definition was real, agreed on, correct, and then it's just expired. The way targets quietly do in a fast-moving retail business. Lesson 3, the definition of success has a shelf life, and it's no one's job to tell you that it's gone bad. 3 different e-commerce situations, 3 different reasons why the definition of success wasn't settled before the work started. None of those were solved by a better model. All 3 were solved or at least make survival in the same way. So here's what it actually looks like in practice. Before you build anything, ask directly, what does success look like and to whom? Not as a formality, but as the actual first task. So if you get 2 different answers from 2 different people, that's not a side conversation to have later. That's the most important finding of the project. And it needs to surface before any code gets written. When you get a vague answer or no answer, treat that as information too. Silence usually means no one's being assigned ownership to that decision, which means that you either need to escalate it and ask who has it, or carefully propose a definition yourself and get it confirmed in writing, so it's a shared decision rather than something that you quietly chose alone, the way that I did with that first recommendation model. And a build-in, a check-in, even an informal one, partway through longer projects, specifically to ask if this is still the goal. Not because you did anything wrong, but because a business that moves as fast as e-commerce does, goals shift. And the only person who finds out after the work is finished is usually you. None of this is on the syllabus anywhere. It is also the actual day-to-day skill that determines whether your works get used or quietly shelved, regardless how good the model underneath it is. Every one of those 3 situations looked at from the outside like a data problem. A model that didn't move the right number, 2 teams disagreeing, a target that quietly went stale, and a decision that no one owned. None of those were fixed by a modeling skill. All 3 were fixed or avoided by the same thing, figuring out early and explicitly whose definition of success actually counted here. And that's not the side skill that you pick up eventually. For most of the actual job, this is the closest to the main skill, and the model is just the thing that you end up building once the question is being answered. If you ever finish something that you were proud of and watch it get quietly ignored, it is worth asking before you blame the model, whether anyone has actually agreed on what success meant in the first place.